Hello guys, so today we'll be studying about the fuel cell, which is a part of the JEE and CBSE syllabus for this year. So we'll be studying this fuel cell in detail. We'll also include the part of thermodynamic efficiency of a fuel cell. So first of all, let us understand what is the construction of the fuel cell. Fuel cell has basically three compartments, as you can see in the figure. So if we go one by one, this is one compartment, say compartment 1, this is another compartment, this is compartment 2, and this is the third compartment. In one of the compartment, the fuel is entered. Here in the diagram we have given it as a fuel, not as hydrogen as in normal textbooks, because fuel cell need not necessarily be made of hydrogen oxygen fuel cell. It can be made of any fuel like methane, ethane, etc. However, we will be dealing with the equations of hydrogen and oxygen fuel cell only. So here, as you can see, the fuel is entering as one chamber, that is, we can consider this as hydrogen, and from the other chamber it is oxygen which is going inside. After this, these are the two porous electrodes. These are the two porous electrodes over here, which allows the flow of molecules of gases from within them. So gases diffuse into the central compartment over here and they react. Before that, hydrogen, while entering the porous electrode on the left hand side, loses the electron and enters as H plus in the central compartment. The electron lost by hydrogen is carried over through this wire and enters the other electrode, wherein this oxygen accepts the electron and becomes OH minus. In presence of water, we are going to study that reaction, and OH minus enters over here. Ultimately, H plus and OH minus combine together and water gets formed, and that water is taken out. While the reaction happens, that is between hydrogen and oxygen, and ultimately water is getting formed, so the heat or the energy that is produced is basically reflected over here as electric current, and this current can be used in various purposes. So the same thing is written pointwise over here. The underlined portions are very important. Electrolyte over here is a resin containing aqueous concentrated sodium hydroxide. Hydrogen is oxidized at anode. Here the anode is marked, and cathode oxygen is going to get reduced. So we are going to now study the reactions that happen in this cell. So if you see the reactions, first of all, what happens at anode and at cathode. So in cathode, what happens? This O2 in presence of water accepts electron, forming 4 OH minus ions. 4 OH minus ions. As we know, the electrolyte already contains aqueous NaOH solution. So hydrogen reacts with OH minus already present in electrolyte to form 2H2O plus 2 electron. So see, in anode the electrons are getting lost, and in cathode electrons are getting absorbed. So in anode oxidation is taking place, and in cathode reduction is taking place. Here there are only 2 electrons produced in anode, whereas we can see 4 electrons are required at cathode. So this reaction has to be multiplied by 2. Now if we want to find out the overall reaction from here, I can easily do that. See, here there are 4 OH minus ions that has been in the reactant side, and here there has been production of 4 OH minus ions, so this can be cancelled out. Similarly, the electron part can be easily cancelled out. So ultimately what remains is 2 H2 plus 1 molecule of oxygen gives, here there is production of 4 water molecules, but here there has been an use of only 2 water molecules, so 2 water. Now what is the heat of the reaction and what is thermodynamic efficiency? Before going into those things, we have to first write down what is the electrode potential of this anodic reaction. So the potential over here is minus 0.83 volt, and the potential, this is the potential for anodic reaction, and the potential for the cathodic reaction is 0.4 volt. So as in this total overall reaction, the total number of electrons are 4 electrons, and here also there are only 4 electrons, so the value of N is same for both the reactions. That is why this 2 is multiplied, so that is taken care in this electrode potential. So if I want to calculate the cell potential, so cell potential can be easily now found out by the addition of these 2, because into 2 part is already taken care in this standard electrode potential. So if I want to calculate this, this will be 0.4 minus 0.83, that is E cathode minus E anode. Answer will come out to be 1.23 volt. So this is the E cell. This will be required in our next part, that is thermodynamic efficiency. What is thermodynamic efficiency? This is the best efficiency that you can get from any machine or any electrolytic or electrochemical cell. So here thermodynamic efficiency is maximum useful work done by heat of combustion. That is what thermodynamic efficiency is. So if we go into this, the heat of combustion of this reaction is del H is equal to minus 285.8 kilojoule per mole. We will use this value. Now what is useful work done? Useful work done is minus NF E cell. So if I calculate by putting all the values, it will come out to be minus 237.390 joule per mole. And if you see, the heat of combustion is minus 285.8 kilojoule per mole. So you can easily convert this into joule per mole, right? You can easily convert this into joule per mole. Now if you just substitute these two values in the thermodynamic efficiency equation, then the equation will give you a result of 83%. So this is the maximum efficiency at standard conditions available from the fuel cell. So I hope you have understood the basic calculation of thermodynamic efficiency. Now we are going to study a little bit factual things which are a part of fuel cell. This fuel cell was first used in Apollo space program by the astronauts in the rocket fuel, okay, that is spacecraft. The water vapor that is produced in this fuel cell was used for drinking by the astronauts. So you can see the use of this. The best and the most important thing of the fuel cell is it is pollution free, number one. Number two, it is highly efficient. It is efficient of around 70%. You might have the question that why it is 70% when I have already calculated 83%. Thermodynamic efficiency is the maximum efficiency that can be available from an electrochemical cell or machines. But the actual efficiency consists of other parts also, like there will be mechanical frictions and all those things are also taken care, and ultimately the electricity produced from the electrochemical cell will be around 70%, because at each and every process there will be a little bit loss. So 83% is the maximum efficiency possible if all other efficiency factors are taken down to zero, which is practically not possible. In thermal power plants, we are having a 40% efficiency. The overall efficiency is 40% in a thermal power plant. Near future, hydrogen powered cars are a reality. So many companies are already doing lots of research on hydrogen fueling stations, hydrogen powered cars, and in near future we are going to see this to be true. Thank you guys.